Alrighty, welcome back everybody. We are on the last room of Linux Fundamentals. This is Linux Fundamentals Part 3. We're going to power up your Linux skills and get hands-on with some common utilities that you're likely to use day to day. I've already started up my attack box over here on the right. Let's see, there is a video that we can watch. This one
Hey everyone.
is 45 minutes, so this is not going to be a quick room. So I hope you guys are buckled in, and I'm probably going to make a whole bunch of mistakes here, but let's get right through it. I do see a deploy machine, so we're going to go ahead and start that so we can get our machine up and running. In the meantime, let's go to the intro. So welcome to part 3 and the finale of the Linux Fundamentals module. So far throughout the series, we have got hands-on with some of the fundamental concepts and use some important commands. This room is going to showcase some useful utilities and applications that you are likely to use day to day. You're also going to advance your Linux flu skills by learning about automation, package management, and service application logging. So, no easy task here. Alright, so we went and deployed our Linux machine. It will give us some credentials once we start. So, in 15 seconds, we should get that. While I'm waiting for that, I'm going to launch a terminal session over here. That way we can SSH, which if we remember was SSH, and it's going to be TryHackMe because that's our username. We're going to put the and at, then we're going to do 10.10.117.117. Yes, and the password is TryHackMe. Bam, alrighty. We have successfully logged in and we've deployed our attack box. So let's start with task 3, terminal text editors. So far we've only stored text and files using a combination of echo and pipe operators like the greater than and the double greater than. This is an efficient way to handle data when you're working with files with multiple lines and the sorts. So introducing terminal text editors, there are a few options that we can use. We're going to be using Nano as well as Vim. Primarily, this room goes over Nano. There's a little bit into Vim. TryHackMe has an entire room dedicated to Vim if you want to get more into that. So, Nano is easy to get started with Nano. To create or edit a file using Nano, simply use Nano and the file name. So, let's go ahead and do that. We'll do Nano. This will be our file. Okay, and there we go. Now we are in our terminal window has transformed as Nano has launched. So we can start entering and modifying our text. So if we put test space, this is a test, and you can hit down and up to start going to different lines. So if we hit down, we put another line, hello world, and we'll do TryHackMe. Alrighty. So Nano has a few features that are easy to remember and covers the most general things that you want out of a text editor, including you can search, you can copy and paste, you can jump to a line number, you can find out what line number that you are on. I just noticed I spelled that wrong, so let's go ahead and fix that. Bam. So you can use these layers by pressing the Control key, which here in the terminal window, it looks like a little caret. So Command G will get help, Command R is read file, Command W is where, Command / is replace. So and Command X is to exit. Alright. So if we want to exit, we'll hit Command and X, and it says do we want to save or not. We're going to go ahead and just hit yes, and file name to write to, we want it to be this is our file, and bam. So now if we do ls, hey, we have something called task 3 as well as this be our file. And then if we really want to, we can do cat this be our file, and now we have all of our entries that we made in Nano there. Alright, then it's going to go into Vim. So Vim is a much more advanced text editor. While you're not expecting all the advanced features, help to mention it for powering up your Linux skills. So some of Vim's benefits, although taking a much longer time to become familiar with, includes it's customizable, so you can modify your keyboard shortcuts. Syntax highlighting, so this is useful for writing or maintaining code, so it's a popular choice for software developers. Vim works on all terminals where Nano might not be installed. And there are a lot of resources such as cheat sheets and a source available to use. So remember, there is a room if you want to get more of that fundamental underneath your waist. But hey, here's the Vim cheat sheet that I was talking about. So we have editing, we have macros, cursor movement, cut and paste. Okay, like there's quite a lot that you can do in Vim. For this module, we are primarily just using Nano though. So create a file using Nano. We did that and we saved it. This will be our file. That's what we made. And it says edit task 3 located in TryHackMe's home directory by using Nano. So again, if we list the contents, we do have task 3 right here. So we're going to launch it in Nano. Excuse me. So remember, it was Nano space then the name, and there we go. So the name of it is, let's see, that's too much. This is going to work right. Let's see. Yep, there we go. So it is THM Text Editors. Alright, so congratulations. So far you have successfully launched Nano, you have saved a file, as well as you have edited. So over here I'm going to close Nano, so I'm going to do that Command X. And because I didn't make any edits, it's not going to ask if I want to save anything above or anything like that. It's just, okay, you didn't change anything, it's fine. Next up, we're going over general and useful utilities. So let's talk about downloading files with wget. So a pretty fundamental feature of computing is the ability to transfer files. For example, you may want to download a program, a script, or even a picture. Thankfully for us, there are multiple ways in which we can retrieve these files. So we're going to cover the use of wget. This command allows us to download files from the web via HTTP as if you were accessing the file in your browser. We simply need to provide the address of the resource that we wish to download. For example, if I wanted to download a file named myfile.txt onto my machine, assuming I knew the web address to get it, it will look something like this, which is wget space the website. So it's access.tryhackme.com/additional links fundamentals part 3 myfile.txt, and it would go ahead and download it. So that's pretty nifty. One thing to do is copy that and paste that for syntax for notes. So wget and URL. Alright, and we can transfer files from our hosts using secure copy, which is SCP. So secure copy is a means of securely copying files. So unlike the regular CP or copy command, this command allows you to transfer files between two computers using the SSH protocol to provide both authentication and encryption. So working on a model of source and destination, secure copy allows you to copy files and directories from your current system to a remote system, or copy files and directories from a remote system to your current system. So provide that we know the username and passwords for a user on your current system and a user on the remote system. For example, let's copy an example file from our machine to a remote machine, which I've neatly laid out on the table. So here we have the IP address of the remote system, which is 192.168.1.30. The user on the remote system is Ubuntu. The name on the local file is important.txt, and the name we wish to store the file on the remote system is going to be transferred.txt. So on the local system, we have important.txt. We want to send it to Ubuntu at 192.168.1.30 and name it transfer.txt. Alright, so with this information, let's craft our secure copy command. Remembering that the format of secure copy is just source and destination. So secure copy scp space important.txt. So that's the local file name, so that's the source. Then we are going to input the username at IP : the directory of home/Ubuntu, as well as what we want to name it, which is transfer.txt. Alright, so let me go ahead and do that and say secure copy. Okay, now let's reverse this in the layout and the syntax using SCP to copy a file from a remote computer that we're not logged into. So the command would look like this. So in this case, the file on the remote system is documents.txt. We're going to store it on our system as notes.txt. Excuse me, sorry about that. The user is Ubuntu and the IP is that same of 192.168.1.30. So this is going to look like SCP. So secure copy Ubuntu at the IP address colon, this is still the source, so the home, Ubuntu documents.txt space, then the destination is going to be notes.txt. So, not too complicated. Secure copy though, you need to know the username of, you need to know credentials for it in order for it to work. Alrighty, so serving files from your host. Ubuntu machines come prepackaged with Python 3. Python helpfully provides a lightweight and easy to use module called HTTP server. This module turns your computer into a quick and easy web server that you can use to serve your own files, whether they be downloaded by another computer using commands such as curl or wget. So Python's HTTP server will serve, or Python 3's HTTP server will serve the files in the directory where you run the command, but this can be changed by providing options found within the manual pages. So remember, manual, you do man space then Python 3. So simply all we need to do is run Python 3 space tackm space http.server and the terminal to start the module. In the snippet below, we are serving from a directory called web server, which has a single named file. So I guess it says as a single file name file. So if we look, we have Python 3 space tackm, then http.server, then it's serving HTTP on this IP address of port 8000. Now let's use wget to download the file using the 10.10.117.117, is that Halo? Yeah, address and the name of the file. Remember, because the Python 3 server is running port 8000, you need to specify this within your wget command. For example, you would do wget http, then IP address of 10.10.117.117 : 8000 for the port /my file. Note, you will need to open up a new terminal to use wget and leave the one that you have started the Python 3 web server in. This is because once you start the Python 3 web server, it will run that terminal until you cancel it. So let me go ahead and copy some of this right here. Copy, and then to get it, you would do, okay, we already got notes on that. So let's take a look at the snippet below as an example. So we got wget with IP with the file. It's connecting, it's connected, the HTTP request is sent, it's waiting response, it came back with that 200 status, and then it's saving, and it's going to have a progress bar, and it ended up saving it. Remember, you'll need to get the wget command in another terminal, keeping this terminal that is running the Python 3 server active. An example of this is on the TryHackMe attack box below. So you have two terminals. The first one is running the Python 3 module http.server, and this one is getting the wget at the IP of the actual attack box, and it's grabbing the flag.txt file. Alright, so one flaw with this module is that you have no way of indexing, so you must know the exact name and location of the file that you wish to use, which is why I prefer to use updog. So what's up, dog? It's a more advanced yet lightweight web server, but for now let's stick to using Python's HTTP server. So ensure you are connected to the deployed instance of 10.10.117.117. So let's see, that is our target IP address. So that is this one right here. Alright, so we are there. Now use Python's HTTP web server to start a web server in the home directory of the TryHackMe user. So where are we? We are in the home directory of the TryHackMe user. We just confirmed that with pwd. So we need to start the web server. So that's Python 3 space boom, and I believe we can just do http.server. Alright, so now that's running on port 8000. Bam. So now on our attack box, we're going to open up a terminal. Remember, this terminal is for IP 10.10.11.112 or 132. So it's not the deployed instance. This is our attack box. Alright, so two separate instances. So what we want to do is we're going to use wget, and we want the file at http 10.10.117.117 port 8000 of flag.txt, and there we go, we got it saved. Cool. Next we're gonna do ls. Where did that just go? We just grabbed it. If you look, it served it. So we saw the get request for flag.txt. Alright, so where did that go? So maybe we want to do find flag.txt. Nope. Let's see. Maybe it's in downloads. Nope. Where did that go? I wish I actually knew exactly where that went to. So let's go and try to find it. Bam. Let's go look at the hint. Use wget. It's a hint file, so don't forget. Okay, that's why. So if we do ls tac all, then we have the flag.txt right there. So because there was a dot there, hey, and sometimes we just need a hint to help us out, alright? So I need to do cat flag.txt. There we go. And now we have the flag. Alright, so let's TryHackMe wget web server. There we go. And submit. Cool. So create and download files to further applying your learning. See how you can read the documentation. Cool. And then we want to go ahead and stop that web server. So there we go with Control C. So cool. We are now moving on to Processes 101. So processes are the programs that are running in your machine. They are managed by the kernel, where each process will have an associated ID with it, also known as a PID. The PID increments for the order in which the process starts, i.e. the 60th process will have a PID of 60. So viewing processes, we can use the friendly ps command to provide a list of running services, so running processes on our user session and some additional information such as its status code, the session that is running it, how much usage time the CPU it is using, and the name of the actual program or command that's being executed. Okay, so decent amount of good information right there. If we just do ps, so this has we have 2 PIDs on that guy going, and we have 2 on this as well. Alright, and their IDs are, their PIDs are different because just how long they've been running and everything else. So in the screenshot, there is the second process has a PID of 204, and then the command below it's 205. So to see processes run by other users and those that don't run from a session, such as system processes, we need to provide AUX, so aux, to the ps command. So we're going to do ps aux, and there's a lot more now on both of these probably. Yep. So over in the example though, there's a total of 5 processes, and notice how we have root and user cnatic. Over here we have root www data. Over here we have TryHackMe, we have daemon, we have SAL1. So quite a lot of different things going on, which is expected. Another very useful command is the top command, and that will give you real-time statistics about the processes running on your system except for one-time view. So these statistics will refresh every 10 seconds, but will also refresh when you use an arrow key to browse the various rows. Another great command to gain insight into your system is via the top command. So let's go ahead and try that. So let's see. Top, and now we got this going on. So this should refresh. Boom, and there you go. It is refreshing, showing what's going on. Next, we can manage processes by using the kill command. We can kill it, kill a PID. So in this one, if there's PID delete, so 1337, you can do kill space 1337. Below are some of the signals we can send to a process when it's killed. So we have sigterm, which kills a process, but it allows it to do some cleanup tasks beforehand. Sigkill kills the process, but don't do any cleanup after the fact. Or sigstop is just to stop or suspend a process. Oh boy, there is a lot right. Okay. How do processes start? So let's start off by talking about namespaces. The operating system uses namespaces to ultimately split up the resources available on the computer, such as CPU, RAM, and priority processes. Think of it as splitting your computer up into slices, similar to a cake. Processes within that slice will have access to a certain amount of computing power. However, there'll be a small portion what is actually available to every process overall. Namespaces are great for security as it's a way of isolating processes from another. Only those that are in the same namespace will be able to see each other. So we previously talked about how PIDs work, and this is where it comes into play. The process with an ID of 0 is a process that starts when the system boots. This process is the system's init, so like initialization on Ubuntu, such as systemd, which is used to provide a way of managing a user's processes, and it sits between the operating system and the user. For example, once the system boots and it initializes, systemd is one of the first processes that started. Any program or piece of software that we want to start will start as what's known as a child process of systemd. This means that it's controlled by systemd, but will run its own processes, although it's sharing resources from systemd to make it easier to identify and the likes. So if we look over here, we have this PID of 1, and its command is systemd. Alright, so that means systemd started, and there was a process that started underneath that. If there were more of them, then we would see more under systemd. Those are just those initial start ones. But there's like kworker, kworker, kworker. So there can be multiple ones, right? And they all have different PIDs. Getting processes and services to start on boot. So some applications can be started on the boot of the system that we own. For example, web servers, database servers, or even file transfer servers. This software is often critical and is often told to start during the boot up by the system administrators. In this example, we're going to be telling the Apache web server to be starting Apache manually, then telling the system to launch Apache 2 on boot. So, in the use of system control, so systemctl, this command allows us to interact with the systemd process daemon. Continuing on with our example, system control is an easy to use command that takes the following format. So system control, option, then service. Alright. For example, to tell Apache to start up, we'll use system control start Apache 2. So that seems simple enough. Alright. So option is start, the service is Apache 2. Same if we want to stop Apache, we replace the option with stop. So we can do 4 options with system control. So you can start, you can stop, you can enable, you can disable. Okay. So that's good to know. Next up, we're doing an introduction to backgrounding and foregrounding in Linux. So processes can run in 2 states, in the background and in the foreground. For example, commands that you run in your terminal, such as echo or things of that sort, will run in the foreground of your terminal, as it's only command provided that hasn't been told to run in the background. Echo is a great example, as the output of echo will return to you in the foreground, but it went in the background. So looking at the screenshot, echo, hi, TryHackMe, and then it displays hi, TryHackMe, echo, hi, TryHackMe, and then we get this one, and that's a little bit interesting. So let's read what it's talking about here. So here we're running echo, hi, TryHackMe, where we expect the output to be returned to us just like at the start, but after adding the AND operator to the command, we're instead just given the ID of the echo process rather than the actual output as it's running in the background. Okay, so this is great for commands such as copying files, because it means we can run the command in the background and continue on with whatever further commands we wish to execute without having to wait for the file copy to finish first. So if you guys remember, in the second part of Linux fundamentals, we went over, actually no, that was the first one. Remember what the ampersand does, and that runs processes in the background, and here's the demonstration of that. Alright. Let's see, so this is great, cool. And we can do the exact same thing when executing things like scripts. Rather than relying on the AND operator, we can use Control Z on our keyboard to background a process. It's also an effective way of pausing the execution of a script or command, like in the example below. So they definitely have a script here, and it's going to say this will keep looping until I stop it. And they hit Control Z, and it did stop. So that's pretty cool. So it stopped until he spins it. Boom. Now our terminal is no longer filled up with the messages until we foreground it, which we'll discuss below. Alright, so foregrounding a process. So we just went over how to background a progress. You can do that with Control Z or with the ampersands operator. Alright, next, foregrounding a process. Now that we have a process right in the background, for example, our script background.sh, which can be confirmed by using the psaux command, we can backpedal and bring this process back to the foreground to interact with. Alright, so we're looking right here. We have the PID of 19802. Alright, by root, and it's our background.shell. Alright, so with our process background, either using Control Z or the AND operator, we can use the FG command to bring it back into focus like below. So where we can see the FG command, it's now going to use background processes to bring them to the foreground like a terminal, where, hey, we said FG, and now the script will keep on looping and looping and looping and looping and looping. Alright, so let's try to answer some of these questions. There's quite a few of them. So read me, correct answer, that's a gimme. If we were to launch a process where the previous ID was 300, what would the ID of the new process be? That would be 301, because it's going in order. Hopefully. Yeah. If we want to cleanly kill a process, what signal would it be? So if you remember, we were talking about killing processes. We had sig term, sig kill, and sig stop. Sig term does cleanup tasks, so that's the one that we want. So sig term. Alrighty. Now locate the process that is running on the deployed instance. So this is our 10.10.10. Alright, so let me go ahead and do this. TryHackMe, boom, let's see, who am I? Alright, so we need to locate the process, and if we remember, let's see, maybe we could do that. Locate the process running on this. Boop, 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 boop. I feel like there are several different processes. Alright, so let's make sure I'm still connected. Am I still connected? Am I still connected? At Linux 3, yep I am. Alrighty. I'm just making sure I'm still there. Alright, so let's see, locate the process that is running on the deployed instance. We can use psaux. We already did that. Let's see, is there a flag somewhere here? Here we go. So there's one, and it says THM processes. Let's see if that fits. It does. Alright. Now what command would we use to stop this service? My service. Alright. So if we're talking about stopping, we can do system control, stop, and then the name of my service. So let's do system control, stop, my service. There we go. And what command would we use to start the same service on the boot up of a system? Alright, so probably want system control, and then we're talking about boot up, so let's look at our option. We have start, stop, enable, and disable. So we're gonna go with start and see if that guy works. Nope, he doesn't, so let's try enable. Bam, and it's called my service. Alright, so if we go back up there, so start is just starting it, while enable is making it good to go for startup on boot. Alright, and then what command would we use to bring a previously backgrounded process back to the foreground? So we're talking about the foreground, it is FG, and that was what we did right here. Cool. So we got through task 5, now we're on task 6. Alright, so we're talking about automation now. So users may want to schedule certain actions or tasks to take place after the system is booted. Take, for example, running commands, backing up files, or launching your favorite programs such as Spotify or Google Chrome. We're going to be talking about the cron process, but more specifically how we can interact with it via the use of cron tabs. So cron tab is one of the processes that start during boot, which is responsible for facilitating and maintaining cron jobs. All right. So this is what cron tab looks like. Okay, it has a specific format that we're going to go over. But a cron tab is simply a special file with a format that is recognized by the cron process to execute each line step by step, and each entry requires 6 specific values. We have the min value, which is for minutes. The hour stands for hours. DOM, so that's the day of month that you want it to execute. The MON, that's the month of the year you want to execute. The DOW, which is the day of the week you want to execute. And the CMD, that's the actual command that you want to be executed. So let's use an example of backing up files. So you may wish to back up this user's documents every 12 hours. So we will use the following. So we'd have 0, then asterisk, /12 for the hour, okay? Then an asterisk, an asterisk, and an asterisk, and the actual command is copy tac r/home user documents, and it's copying those over to /var/backups. All right. An interesting feature of cron tabs is that these also support the wildcard or asterisk. If we do not wish to provide a value for that specific field, we don't care what month, day, or year it's executed. Only that's executed every 12 hours. We simply place an asterisk. That's why there are so many in this line right here. This can be confusing to begin with, but don't worry. There's resources like the cron tab generator, which if we go here, it will spit it out for us. So let's say we want a job to run every 6 hours, every 10 days, on odd months, every day. All right. Then let's just say we want to run ls. All right. So it's saying asterisk, */6, */10, 1, tac 11/2, tac. So I very much would recommend either using the tool cron tab generator or, whatever tools you can, alrighty, because it really does help. It's not that it's impossible, it takes time to learn, and then remembering exactly what each one of the values is. So this looks to be a little entry right there, which was the example that we just read about. So ensure you're connected to the deployed instance and look at the running cron tabs. Alright, so I believe this one is mine, and what I want to do is I want to do cron tab /e. Okay. Alright, now it's in nano, so I can hit down. We can keep going. Okay, so this has right here, it says at reboot, it's going to run this command. So when will the cron tab on the deployed instance run? And that is at reboot. There we go. Cool. Next up, we are maintaining your system package management. Let's do a sneak peek right here. Oh, this one we only have to read, so that's kind of nice. Alright, so let's read. Introducing packages and software repos. So when developers wish to submit software to the community, they will submit it to an apt repository. If approved, their programs and tools will be released into the wild. Two of the most redeeming features of Linux shine to light here: user accessibility and the merit of open source tools. So when using the ls command on Ubuntu 20.04 Linux machine, these files serve as the gateway registry. Alright, so if we look, we have all these guys. Alright, and we can look at the sources list, which will tell us that we have several repositories here. Alright, so while operating system vendors will maintain their own repositories, you can add community repos to your list. So this allows you to extend the capabilities of your operating system. Additional repos can be added by using the add tac apt tac repository command, or by listing another provider. For example, some vendors will have a repo that's closer to their geographic location. All right, so let's look into managing your repos, adding and removing. So normally we use the app command to install software onto our Ubuntu system. The app command is part of the package management software, also named app. So app contains a whole suite of tools that allows us to manage the packages and sources of our software and to install or remove them at the same time. And one method of adding repositories is using the add tac app tac repository command we illustrate above, but we're going to walk through adding and removing a repository manually. While you can install software through the use of package installers such as dpkg, the benefits of app means that whenever we update our system, the repo that contains a piece of software we add also gets checked for updates. All right. So in this example, we're going to add the text editor Sublime Text to our Ubuntu machine as a repo, as it's not a part of the default Ubuntu repos. All right. When adding software, the integrity of what we download is guaranteed by the use of what is called GPG, which is New Privacy Guard keys. These keys are essentially a safety check from the developer saying, here's our software. If the keys do not match to what your system trusts and what the developer used, then the software will not be downloaded. So trust in the integrity of it. So to start, we need to add the GPG key for the developers of Sublime Text 3. Note that TryHackMe instances do not have internet access, so we're not expecting you to add this to the machine that you deploy, as it would fail. Alright, so if you have Ubuntu or another instance of Linux running at home, go ahead and follow this along, which is, let's download the GPG key, use the app key to trust it, which is wget, and then we're pulling it with that flag. We are downloading from Sublime Text, we're getting their GPG key, and then we are doing sudo app key add as the command for that. Now that we have added this key to our trusted list, we can now add Sublime Text 3's repo to our app sources list. A good practice is to have a separate file for every different community or third-party repo that we are going to add. So let's create a file named sublimetext.list in this directory right here, that sources.list.d, and enter the repo information like so. So it says touch, Sublime Text List, this, boom. Alright, there you go. And now use nano or text editor choice to add and save the Sublime Text repository to this newly created file. So now we can add that. So after we've added this entry, we need to update apt to recognize this new entry. This is done using the app update command. Then once successfully updated, we can now proceed to install the software we trusted and add using app install Sublime Text. So you're reaching out, you're getting the this right here, the GPG key, so you know that the integrity of the file that you're installing is there and it can be trusted from the developer. Then you're adding the actual, you're adding your source list to say, hey, we're good to go on this repository, right? And then you want to update it, and then you can actually install what you're going for. So it is a little bit of extra steps, but once you get the hang of it, it's not that difficult. All right. Next, removing packages is also as easy as reversing the process done by add app repository tac remove. And then you'll have this command over here, or by manually deleting the file that we previously added. Once removed, we can just use app remove with a software name. So app remove Sublime Text, and it would get rid of it. All right. So you're adding repos, you're trusting repos, you're adding repos, you're taking away repos so that you can then download software or really anything from said repos. All right. So we have task 8, and then we have conclusions. So let's finish strong. I know this is a long video. We have maintaining your system logs. So we briefly touch upon log files and where they can be found in Linux Fundamentals Part 1. However, let's quickly recap. Located in the var log directory, these files and folders contain logging information for applications and services running on your system. The operating system has become pretty good at automatically managing these logs in a process known as rotating. So They've highlighted some logs from 3 services running on an Ubuntu machine. So we have an Apache 2 web server right here. We have logs for the fail to ban service, which is used to monitor attentive brute forces, for example. So fail to ban logs are right here. And then the UFW service, which is used as a firewall. So we have our firewall logs. So these services and logs are a good way to monitor the health of your system and protecting it. Not only that, but the logs for services such as a web server contain information about every single request, allowing developers or administrators to diagnose performance issues or investigate intruders' activity. For example, there are 2 types of logs below that are of interest. We have an access log and an error log. So we look, we have access log, all those. Then we have error logs. There are, of course, logs that store information about how the OS is running itself and how the actions are performed by users, such as authentication attempts. So, on our deployable Linux machine, that is this guy right here. So let me exit out of cron tab. Cool. We need to look for the Apache logs. Alright, so what we want to do is we're looking for Apache 2 logs. So we want to change to /var/log, and we'll do ls. Alrighty, we do have Apache 2 right here. So look for the Apache 2 logs. So maybe we can do nano Apache 2. Nope, nothing is in there, so let's exit out of there. That's not the right one. I don't see access logs. So let's go and do hint. Okay, then oh, we just have to go one more. We just have to drill down one more. Oh, come on. So let's do cd Apache 2 ls. Cool. Now we have some. So we now have these guys. Alright, what's the IP address of the user who visited the site? So let's look in the access log. So we'll do nano access log. Error permission. Alright, so we do not have access. So let's try log.1. Alright, so let's do nano access log.1. There we go. Alrighty, so the IP address of who visited, it's going to be 10.9.232.111. There we go. And what file did they access? They accessed catsanddogs.jpg. So catsanddogs.jpg. There we go. Alright. So that was cool. We found where our logs were at. We then opened them up properly. And now we're at the conclusion and summaries. So, welcome to the end of the Linux Fundamentals module. Your familiarity with Linux will improve as you get to interact with it over time. Linux has the potential to do very powerful things with relative ease. To recap, this room has introduced you to using terminal text editors like Nano and Vim, general utilities such as downloading and serving contents through a Python web server. So, I don't know if you guys remember the wget, that type of stuff. You could also use curl. I look into processes, so that was all the PID information and whatnot. And then we are maintaining and automating your system using cron tabs, package management, and reviewing logs. So if you want to continue on your Linux path, you can look into bash scripting and regular expressions. We're going to go ahead and terminate this machine. Boom. And we are going to hit complete here, but we are going to finish out this pre-security module with Windows fundamentals next. And then that is all that she wrote for the pre-security module. So thank you all for watching. Hope you learned something as well. And that was a long video, so hope we all got through it together. If this complete will go through, then hopefully we'll get the little good screen. So we're at 100% completed. We have our congratulations on completing Linux Fundamentals 3. So good job, everybody. I'll see you guys in the next one.